Hello and welcome to this GDS Lab 2024 tutorial 5.4.5 running a dynamic cyclic VDDCSS. So the VDDCSS apparatus is an advanced soil testing device designed to simulate complex shear conditions. It extends the functionality of conventional shear apparatus by adding another axis of control, making it possible to apply cyclic loads in different directions. This advanced capability is especially useful for dynamic soil testing, like replicating the shear stress conditions experienced during earthquakes or under cyclic traffic loads. So at the moment we're on our test setup tab, and we can see that we've currently got in the test module list dynamic cyclic loading listed. So those of you that have seen the first video of this running a VDDCSS would have known selected advanced loading. This time we're selecting dynamic cyclic loading, and the difference between the two means we unlock these dynamic controls and lead in, lead out controls at the bottom here. So just like before, we have our axle control, so we can choose anything from displacement and load, and we also have an LVDT option for the displacement, which is similar to normal axle displacement but using a linear variable differential transformer over a short range transducer. Then on the horizontal x-axis we have the usual options, so displacement x-axis, displacement LVDT-axis, horizontal load x-axis, and then we have the total shear displacement LVDT, and total shear load. These are shearing parameters that we can now use, which wasn't on the previous test. So these total shear options, what that does is automatically deactivate the y-axis control, as this mode combines both x and y shear forces into a single parameter. This option introduces additional control options like angular frequency and angular displacement, providing more precise control over complex shear motions. And you also have an LVDT option too. So to show this, there we go, it's gotten rid of the y-axis because it's combined the x and y here. But I'm not going to do that, so I'm going to set it back to horizontal displacement. I'm going to go ahead and put in a few values. So for example, I will put my datum of axle displacement at 2, and then my amplitude at 0, with my phase angle at 0. Then my horizontal x-axis I'm going to leave at 0 with an amplitude of 0.25 and my phase angle at 0 still. And then my horizontal displacement on the y-axis is going to be the amplitude of 0.1 and the datum of 0 and the phase angle of 0. And I'm not going to use my back pressure and cell pressure controls, but you do have this option if you want to use it. Then, now to the new part, the dynamic control. So I'm going to put in my frequency at 0.1, my horizontal x-axis frequency at 0.1, and my horizontal y-axis at 0.1. Then I want my total cycles to be 50, and my points per cycle to be 100. So regarding setting your frequencies, you typically want a lower frequency for slower dynamic processes like long-term traffic loading, or if you want it higher, for example 1 Hz or more, that would simulate rapid loading events such as vibrations or earthquakes. So depending on what test you want, that's where you select your frequencies. And the lead-in, lead-out times, you can set an example for this, but I'm going to just leave these all as 0. It does need an input because it's not an optional parameter. But if you did want an example, you could put a lead-in time of 10 seconds, and then you could put a magnitude of 1. But anyway, I'm not going to do that. So again, like I said, I will leave them at 0. So once you've done all of this, you can then go ahead and click apply, and then go to your test. Now, unfortunately, I don't have the correct equipment to run this test to view it properly as the way you would expect. So this is going to be the end of the video. But anyway, thank you very much for watching. This has been running a dynamic cyclic VDDCSS. Thank you.